Okay, this problem says if x to the third times f of x squared equals 348 and f of 2 equals 3, find the derivative at 2. Well, this looks different than maybe some of the problems we've done before, but it's actually just kind of the same problem that we've been looking at with implicit differentiation. What you got to remember here is that f of x, another way to write that is y. And so if we just put y in there, now this looks a lot like that implicit differentiation problem. And that's what we're going to use to solve it. But there's some other information you got to catch from this too. Over here it says f of 2 equals 3. What that tells us is that the x value, when the x value is 2, the y value over here is 3. And so that also tells us what we're finding here is that we want the derivative of f. Another way of writing derivative is the dy dx. We want to find that when x equals 2 or at the point 2, 3. Because we know when x is 2, y is 3. Okay, so now let's do our implicit differentiation with this one and see. Here it looks like we are going to have to do product rule, so I'm going to take the first one times the derivative of the second, which would be 2y, but it's a y, so we got to include dy dx, plus, because we got to do the other part of the product rule, y squared times derivative of x cubed, which would be 3x squared, equals, and we got to do derivative of the side, constant, that'd be 0. Now, we could solve for that dy dx like we've done in the past. When you know a point, though, like we do here, it's way easier just to start plugging in now and then solve for the derivative dy dx. So anywhere there's a 2, or x, we're going to plug in 2. Anywhere there's a y, we're going to plug in 3. So if we do that, we got 2 cubed times 2 times 3 dy dx. Here we're going to have 3 squared times 3 times 2 squared equals 0. Let's do some multiplying. 2 cubed is 8 times 2 is 16 times 3 would be 48 times dy dx. 3 squared is 9 times 3 is 27 times 2 squared or 4 would be 108. Now let's minus the 108 and divide by 48, and that tells us that our derivative dy dx is negative 108 over 48. That can be reduced, so if you go on your calculator, I think 12 goes into both of those. It tells us that our derivative evaluated at the 0.23 ends up being negative 9/4, or with function notation, that's f of 2.